Hello, everyone, and welcome to today's session on optimizing storage price performance for Amazon S3. I am Arushi, and I'm joined by my colleague here, Carl. So today, we will focus on what steps you can take to optimize what you store and how you access your data from S3. In this session, we'll talk about how customers monitor their storage, how they optimize storage when they have known or changing access patterns, how they achieve really awesome performance with Amazon S3 with minimal effort. The goal of this session is that by the end of it, you will walk away with a series of concrete steps that you can take to optimize how you use Amazon S3. But let me first start with a topic that has been transforming industries today, something that I'm sure all of you have heard a lot in these days. And then I'll tell you why your data actually forms the base of this transformation. Any guesses to which technology I'm talking about? You're right. Generative AI applications. So customers acknowledge the power of generative AI applications in outlining the vision of their organizations. But the interesting thing is that most folks talk about only the foundation models. Now, while that is very important, that's just the tip of the iceberg. There's a lot going underneath. Generative AI applications are still just applications. And you should think of them just as a new application that's sitting on top of your already existing data. So what that means is you want to take advantage of the already existing data of your organization. And you want to build applications that are compatible with that data. So in the end, it's really the underlying data that you want to use more efficiently. And one of the key components of being able to use your data more efficiently is to focus on how to optimize your cost and performance. And that is the conversation, that is the topic of today. Now, AWS is an excellent place to build your data strategy. With the AWS, you get a wide variety of applications that you can use. For GenAI, for example, you need to store various types of data, including unstructured, structured, streaming, and vector data that can be used to customize your models. So from storing, querying, to analyzing your data, and finally putting all of that to work is what you can do with AWS. But what that basically means is that it's your data that is the differentiator. When you want to build GenAI applications, or any applications for that matter, that you need to use the data that is unique to your business, because that is what tells you how to most optimally use it. To store data in AWS, you can use Amazon S3. It is the cloud object storage with industry-leading scalability, data availability, security, and performance. When Amazon S3 was launched back in 2006, it was a storage for the internet. And today, we see customers across all industries of all sizes using Amazon S3 for every imaginable workload. This spans from running data lakes to storing large amounts of data to train their GenAI models, to running analytics applications to derive business intelligence. And the thing that so many customers love about Amazon S3 is its price performance and the elasticity to scale storage up when you need it and down when you don't. And why is it so important to scale your storage? Because data is growing rapidly. Customers tell us that there is so much value in storing, processing, and learning from these data sets. And they want to do it in a cost and performance optimized way. So let's start with cost for today. When we see customers managing large amounts of data sets, often they organize their thoughts around a few pillars. As a first step, you want to define your workload requirements. What you really want to do is to understand how your organization is using your data. Once you have defined your workload requirements, you want to understand your storage and then develop insights about your storage. And lastly, you want to be able to optimize your storage and measure the results. Now we get it. You want to understand your workload requirements and define them. But after that, have you ever thought, why is it really important to get insights out of your storage? Because if you do not understand your storage well, you cannot take actions to optimize it. When customers just get started with AWS, they'll probably have a very small storage footprint. You might have a handful of objects, and it might be easy to individually dig into every account, every bucket, and make sense of what is happening in your storage. But as you grow, you'll have billions of objects. And that is when the same thing gets a little tricky. You cannot optimize multiple buckets across many accounts. These customers, they want to be able to understand how to use their storage across the organization. So to develop insights, we try to understand what our customers are asking for. And we understood that customers want to gain visibility into their usage, to avoid having to go bucket by bucket and account by account to gather details. Secondly, they want the ability to analyze their data at the granularity that they need for root cause analysis. And then they also want the ability to get meaningful insights, which enables them to take the right actions. Gathering all of this feedback, we had launched Amazon S3 Storage Lens. It gives you an organizational-wide view of your object storage, which you can use to improve your Amazon S3 cost and the performance. Storage Lens provides a single view of your storage usage across hundreds of accounts in an organization. And you can even drill down to up to a prefix level. It's a visual and interactive dashboard built into the S3 console. And perhaps most importantly, what you need to know is that everyone should use it because you get a bunch of metrics for free. Over the last few years, almost all of our S3 customers have been using S3 Storage Lens to make decisions about their growth of data and to get deeper visibility into their storage. For example, if you might have a question, how much has your storage grown over the last 90 days? Now, that's something you can figure out with S3 Storage Lens. It helps you not just find improvement opportunities and cost optimization, but also information on how you can optimize your data protection, access control, and performance, and much more. Within the context of S3 cost optimization, S3 Storage Lens helps you continuously monitor your entire S3 footprint. There is a lot more that you can do with Storage Lens, and I'll give you more examples. But first, I want to go over two major features. You can aggregate Storage Lens metrics using custom filters. For example, object tags, object size, age of the objects, and much more. It allows you to see your metrics at the aggregation level that's best for you. So for example, if you try to aggregate your metrics based on file extensions, you can find what type of data is stored in your storage. You can also see, perhaps, that how much of your usage of a data lake comes from a specific file format. Say, how much is coming from Parquet file format. We also announced that you can view all of your activity metrics, like the number of GET requests, PUT requests, the volume of bytes uploaded and downloaded from S3 at the granularity of a prefix level. Similarly, you can also look at the status code metrics, like 503 slowdowns, at the prefix level. This makes S3 Storage Lens a great place to go when you need to troubleshoot performance issues. Now let's see what S3 storage lens actually looks like. This is the screenshot of the page, which gives you an organizational view of your storage footprint. Now, this is more of a starting point, and you might not be able to take immediate actions based on this information, but this actually makes you understand what's happening within your storage to help you figure out where you should drill deeper. Let me show you something very cool that you can do with Storage Lens. So this is a bubble chart that helps you compare your buckets across 3 dimensions. Each bubble represents here a bucket. So bigger the bubble, that bucket has more amount of data. On the x-axis, we have object count. So further towards the right, the bubble is, it means more number of objects are there in that bucket. And on the y-axis, we have retrieval rate. So higher up, you see a bubble, it means that data is accessed more frequently. So now you focus on the highlighted bucket here. So that bucket has a big bubble, which means that amount of data in it is huge. Secondly, the retrieval rate is way lower. So most of the data is probably not getting accessed. So this can be an interesting bucket for you to look at. Maybe a lot of objects, maybe say 9 out of 10 objects in this bucket are not getting access frequently. This gives you an opportunity to think about adding lifecycle policies and transitioning that data into a storage class which has a lower cost. And there, you're saving money. Another awesome thing you can do with S3 Storage Lens is to identify incomplete multi-part uploads. For background, multi-part upload accelerates your uploading of objects by splitting it into logical parts, which can be uploaded in parallel. Now, while the uploading is going on, all these parts are stored in S3 till the request either stops or completes. So you are also paying for these parts. Now, in this graph, the red line is the object count, but the blue line shows the incomplete multi-part uploads, which are older than 7 days. Now, maybe you don't need the incomplete multi-part uploads older than 7 days. They might not succeed, and it makes more sense to add a lifecycle policy to probably delete them. So as a best practice, all of you should be looking at setting a lifecycle policy which deletes incomplete multi-part uploads that are older than some specific number of days. And to set this lifecycle policy, you can do it right on the S3 console by navigating to that particular bucket, clicking on the Management tab, and then creating your lifecycle rule. Another similar scenario you can get is with the versioning control. If you are using S3 versioning, S3 will store multiple non-current versions of your object. In case there is an accidental deletion of your object or an overwrite of your object, you can use these older versions to retrieve your data. But it's possible that you have way too many non-current versions, which you might not need. They might be redundant. So you can easily use Storage Lens to figure out how many of those non-current versions you have and set lifecycle policies to maybe delete them or move them into a colder storage class. Now, in addition to S3 console, you can also publish your Storage Lens metrics to Amazon CloudWatch. This route is very useful if you use CloudWatch to create a view where you can monitor your S3 Storage Lens metrics along with some other application metrics using CloudWatch dashboards. One neat thing here is that you can set up notifications using CloudWatch alarms. So for example, you can set up an alarm that if there is an increase in the number of incomplete multi-part uploads, you will get an alarm. And you can go ahead and then see that, oh, there is a lot of incomplete multi-part uploads. So you can set up a lifecycle policy to transition them. Now we talked about what you can do to see your storage at an organizational level and drill down up to a prefix level. But what if you want to understand at an object level? For that, you can use S3 inventory. It lets you report your storage by listing all the objects and even giving you metadata associated with those objects. Metadata, for example, object name, size, the replication status, encryption status, etc. Moreover, a lot of our customers also use S3 inventory with Amazon Athena. Now, Athena is used to derive insights with SQL queries. So you can use it for ad hoc data discovery, and you can use it to filter your data from the S3 inventory. For example, you can query using Amazon Athena only to give you all the non-current versions of an object. Now let's talk about storage classes, which are optimized for different kinds of data access patterns. Now, storage classes are a construct where you store data in S3. And before choosing a storage class, you need to identify which storage class to choose. And that's where comes the patterns of cost optimization, because we see that typically workloads fall under two categories. You might have a known or a predictable access pattern of your data when you know when your data is going to move, where it's going to move. And the second one can be an unknown or a changing access pattern. To start with, let's talk about the known or the predictable access pattern. For example, think about a use case like sharing photos and videos with your friends and family. You know when you upload data, and you know when it will be accessed and when it will be not accessed. It might, as soon as you upload it, it will be accessed very frequently, and maybe after a couple of months, you do not go back and look at that data again. In such a case, you have a known or a predictable access pattern. So for such a case, as you can see here, it started with a very high retrieval rate. Your data is getting accessed very frequently, but over time, maybe in a couple of months, your data is obsolete, and you're not using it again. This is again a screenshot of the S3 storage lens, which shows you a similar example. The blue line is the total volume of data stored, and the red line shows the retrieval rate per month. And often customers with predictable access patterns observe that the percent of data accessed each month is consistently low after the data becomes rarely accessed. So based on this, you can think about adding a lifecycle policy to move this data to a lower storage cost. So now, let's move towards the storage classes that we have. If you have a use case with a known access pattern, you want to choose a storage class that best matches your requirements. S3 has a large number of storage classes to choose from. And we are going to talk about how to decide which storage class to select. Let's start with the first one. S3 standard. So now say you have a content streaming use case where you're using S3 as your origin of your data. Now, that data will be very frequently accessed. And in such a case, you should use S3 standard. It is a storage class that is designed for frequently accessed data. And it is the best choice if you are accessing your data more than once a month. But let's say now you store and analyze your data in data lakes. Those images may become infrequently accessed over time. In such a case, you should use S3 standard infrequent access and save on the storage cost because it costs lesser than S3 standard. S3 standard infrequent access and the other storage classes to follow, they are designed for infrequently accessed data. So your storage cost decreases, but keep in mind that the cost to access data out of those storage classes increases. Now, S3 standard infrequent access is the ideal storage class for data that you access once every month or two. But now let's move to the next one. Maybe you have, say, medical records. So that data must be accessed immediately, but it's probably accessed only a few times in the whole year. In such a case, you should use S3 Glacier Instant Retrieval, which is the ideal storage class for data that's accessed maybe once every quarter. But now if you have an archive data use case that does not require immediate access to the data, but it is kept for a long period of time, maybe logs or compliance data. In that case, you should use S3 Glacier Flexible Retrieval and save further on storage costs. It delivers additional cost savings over S3 Glacier Instant Retrieval and offers retrieval in minutes with expedited retrievals, or you can get retrieval in 5 to 12 hours using free bulk retrievals. So that's why it's ideal for a backup or a disaster recovery use case. And lastly, for long-term archives, you should use S3 Glacier Deep Archive, which has the lowest storage cost in the cloud. But the retrieval times are from 12 hours to 48 hours. Now, focus a little bit more on the Glacier storage classes. Every industry has an archiving use case, from sport highlights or news broadcasting content to medical images and genomic sequencing data. In fact, if you take a step back and think about maybe your business or your ideas, you'll realize that you too have some of the other archival use case. Maybe you just want to store the historical data of your application for future, when you might want to read that data to understand the patterns of your business. Keep in mind that whenever you see Glacier in the name of a storage class, it is designed for an archive use case and for data that's more infrequently accessed. Now, I know we're not yet on the performance section, and Carl will talk more about it, but I want to highlight that last year, we announced that S3 Glacier Flexible Retrieval has improved its retrieval performance time by up to 85%. This performance improvement automatically applies to standard retrievals made through S3 batch operations. From restoring large backups to pulling down data to train a machine learning model, everything is now faster. This is an example in live that you can see after our tests. Restoring 250 objects and a total of 25 gigabytes. So the blue line shows the previous restore performance for objects with S3 Glacier Flexible Retrieval. And you can see in the next slide that there was an improvement. There was a massive improvement after we released the improvement of our retrieval times of S3 Glacier Flexible Retrieval. The job, which used to take 3 to 5 hours, finished in less than 30 minutes. Ancestry is one of our customers who mentioned that they benefited from this improvement. They do some awesome machine learning for handwriting recognition and training their models on handwritten historical documents, many of which are stored in S3 Glacier. So Ancestry restored hundreds of terabytes of images from S3 Glacier Flexible Retrieval within hours instead of days. They're able to train against massive data sets in a very cost-effective way because of this improvement. So to recap, in choosing the storage class, there are really 3 factors that you should consider. One is the frequency of access, how frequently you will be accessing your data. Second, how long your data will be sitting in a storage. And third, definitely, is the performance, how quickly you want to retrieve the data from the storage class. There's another important angle to consider around the duration of storage and the average size of your objects. Not only is it important because some of the storage classes have a minimum retention period, but also because they have transition costs. A minimum retention period means that you have to store data for that much amount of time, and if you delete or move your data before that amount of time, you will still pay for the minimum retention period. And transition costs mean that even with lifecycle policies, when you're transitioning from a hotter storage class to a colder storage class, you will pay for the transition of the data, and that cost is per object. So in this example, we are comparing the cost savings between S3 Glacier Deep Archive and S3 Standard. So this shows that if you move your data from S3 Standard to Glacier Deep Archive, you should consider that if you will be storing your data for at least 20 months, if you have an object size less than 128 kilobytes. But this break-even period shrinks as your object size grows bigger. For example, at 1 MB, you'll start to save money just within a couple of months. OK, so I've already spoken a little bit about lifecycle policies. But to give you a full picture, lifecycle policies are actions that S3 takes on group of your objects. And there are two types of actions. One is a transition action, which moves your data from a hotter storage class to a colder storage class. And the other is an expiration action, where S3 deletes your object. So you can look at fine-tuning your lifecycle policies. For example, in the content sharing use case, maybe you can think about transitioning your data in 90 days from S3 standard to S3 Glacier instant retrieval, because your data is getting less and less retrieved. Now, we already talked about the known and predictable access patterns. But what if you just don't know your access pattern? You don't know when which data is going where. And guess what? Majority of the data has an unknown access pattern. From tables in your data lake to the historical data that you suddenly decide to use to fine-tune a machine learning model. It's particularly challenging to predict when an individual object is going to be accessed. But you want to optimize at an object level. And for that, we have a different storage class. Because for you, you cannot figure out of these storage classes where you want to place your object. And that is where you should use S3 intelligent tiering. This is a storage class that consists of multiple access tiers. Your data always starts from the frequent access tiers and is transitioned to the colder access tiers based on the last access date of your object. With S3 intelligent tiering, there is no charge for the transition of your data, but you only pay a small monitoring fee, which is used by S3 to constantly monitor your objects and automatically transition your data into colder access tiers. So your data, starts from frequent access tier. If it's not accessed for 30 days, it moves to infrequent access tier. Within 60 days, it'll move to the archive instant access tier. All the first three access tiers have the same performance as S3 standard, so the data is immediately accessible. If you also want, you can optionally also use the last two access tiers, which are asynchronous access tiers. By default, if your data is not used for 90 days, it'll transition into the archive access tiers, and in 180 days, it'll transition into deep archive access tier. But you can look at fine-tuning these policies. So in summary, S3 intelligent tiering can further optimize the storage costs. And if you have a use case where you have an unknown access pattern and you're not using S3 intelligent tiering, trust me, this is probably the single best way that you can save money on your S3 storage costs. Another cool thing about the last two asynchronous tiers is that you can monitor the data movement in these tiers using event notifications. So for example, you can configure event notification to track when an object moves to the deep archive access tier within intelligent tiering, which means that your application will already know that this data might not be immediately accessible. It can take several hours. So you can fine-tune your applications accordingly. While a lot of customers are using S3 intelligent tiering, one of our customers, Illumina, talked to us and told us that they were struggling with storing hundreds of petabytes of genetic data at a low cost. They moved roughly 50 petabytes of data to S3 intelligent tiering, and within 3 months of using it, they saw a 60% reduction in their storage costs. And these are really impactful results and really tell us that our customers should try it. Overall, customers have told us that since the launch of intelligent tiering, they have saved more than $2 billion. These are really exciting and encouraging results for us because customers tell us that they use this money to finally innovate in their own business instead of having to manage their S3 infrastructure themselves. So we talked about cost. Now let's switch gears and talk about performance optimization. Thank you.
All right, so as we've heard, optimizing cost is obviously critical and important, but equally important is optimizing our application's performance. Now, with Amazon S3, you can scale to tens of millions of requests per second. And it's this capability that allows customers like Netflix to serve billions of hours of content, or for FINRA to be able to analyze 37 billion trading records every day. So over the next few minutes, we're going to take a look at how customers like those think about designing their applications for scale and performance with S3. S3 is a large distributed system, and our client code, our customer code, in fact, your code, forms a part of that system. And when we think about designing for performance with S3, we think about it in three kind of areas. The first is maximizing your request rate, making sure that you can make the request you need. Then we look at minimizing the latency of each of those requests. And finally, we want to achieve the maximum possible aggregate throughput for your applications, getting your data into and out of S3 as quickly as possible. S3 automatically scales to high request rates, such that each prefix in S3 can achieve 3,500 TPS of puts, 5,500 TPS of gets. Now, it's a bit cliche, but to give you a frame of reference for that, at 5,000 TPS, you can download each of the 31 million books in the US Library of Congress 14 times every day. And what that means is that for the vast majority of S3 customers, this is not something you need to worry about or do anything special about. But as we heard earlier, workloads change over time, and they're not always predictable. And perhaps you may need to burst above these numbers. So we're going to talk a little bit about how you can help S3 scale to meet your needs. As an example, suppose we have a large fleet of autonomous vehicles. And every night, they want to upload their anonymized drive data into S3 for use in an ML training pipeline. A reasonable first cut at the key structure looks like the one behind me, where we have a parent folder for the daily uploads. We have today's date. We have the car's unique identifier. And finally, one or more keys for the data itself. Now, 6 or 6:30 in the evening rolls around, and everybody in North America wants to upload their data, or all the cars do at least. And as the number of cars grows over time, we will start to see more and more TPS against this shared prefix. And in this case, that's the date. Now, in a given night, some of your vehicles might start to see some initial throttling occur, 503 slowdowns from S3. But over the course of the evening, S3 will learn the traffic patterns and see that there are some what we call split points here in your incoming traffic, and we'll be able to split your TPS against this pattern. In this case, it'll be the car's identifier. And by the end of the evening, each car or group of cars will have their own kind of dedicated allotments of that 3,500 TPS of puts. Now, of course, fortunately for us, but maybe not so much for the system that we built here, tomorrow arrives, and now S3 will have to learn this pattern all over again. But there's a relatively simple fix for this. If we simply swap the date and the car's identifier, then S3 can learn this pattern one time at the beginning of your application's lifetime. And each car or group of cars will have that dedicated allotment of 3,500 TPS of puts from the very beginning moment of being in production. Now, as we mentioned, workloads change and they grow over time. And when your applications exceed the numbers that we've talked about, S3 may respond with a 503, a slowdown. This indicates that there may be areas of your key space that require attention. You can use request metrics, S3 request metrics in CloudWatch to monitor an alarm on 503 errors. And then you can use S3 Storage Lens advanced metrics to identify the prefixes that are generating those 503s. And finally, in order to dig into the problem, you can use S3 server access logs to identify the specific application or maybe even user that's generating that increased traffic. All right. Now, our customers use S3 from a wide variety of locations, anywhere from meters away in an EC2 instance from their data in S3, to mobile devices accessing the internet over 3G, to literal spacecraft beaming telemetry or imagery from Mars. And to accommodate that wide variety of use cases and locations, our SDKs ship with relatively conservative settings for things like how long they're willing to wait to establish a connection or to receive a response to a request for data. And so the most impactful thing you can do to control your latencies from the client and to reduce your time to the first useful byte is to tune your client timeouts to match the environment and location your applications are running in. And you would be using the same tools that we just talked about to identify the expected latencies of your application in its production environment and use those expectations, for instance, the 95th percentile, to set the timeout on your client so that your slowest requests are timed out and then retried. And that retry is very likely to take a different path to and within S3 and see much better latency and throughput. Now, the key to maximizing throughput with S3 is parallelization. Your applications should open and reuse as many connections as your host can support, and issue as many concurrent requests for data from S3 as you can or need. But there is one element of parallelization that I want to mention a little bit more in detail. Now, it's kind of obvious, but as the amount of time required to upload or download an object will grow with the size of the individual object. So to achieve the best aggregate throughput, we recommend making multiple requests, even within the same object. So when you're retrieving data from S3, use range requests or byte range fetches to make multiple smaller requests for different parts of the object. And like Arushi said, when you're uploading data, make use of the multi-part upload APIs to upload the parts in parallel. So we're going to go over these a little bit more here. So just to recap, first thing to do is to ensure that you're parallelizing your requests for objects even within the same object. Next, you want to ensure that you're using multiple connections and reusing them in order to amortize the cost of their setup. Importantly, you want to make sure that your connections are to a wide variety of S3 IP addresses. We recommend making no more than about 5 to 10 connections per IP address. And we recently launched multi-answer DNS to make that a little bit easier, to give you multiple IP addresses in a single resolution. And of course, you'll want to monitor the performance of those individual connections and those individual IPs, and tear down those connections that aren't performing well. Remember to tune your client timeouts to fit your application's network environments, canceling those requests that are taking longer than about the 95th percentile and retrying them. And of course, when retrying, make sure that you are backing off exponentially after the first retry, and also adding jitter to your wait times to maximize the likelihood of your application succeeding. And finally, there's a number of things that were outside the scope of this talk, but for instance, we see data movement across NUMA domains, significantly affecting your network throughput. And so we recommend that you pin the threads handling your requests and connections to a specific NUMA domains for their lifetime. But frankly, that sounds like an awful lot to keep in mind. And I don't want to have to worry about it, and I don't want you to have to worry about it. And so we built these best practices and more into something called the AWS Common Runtime, or the CRT. The CRT is a set of native libraries that underpin many of the AWS SDKs, client connectors, and tools, and it provides, out of the box, all of those throughput and latency improvements that we just talked about. Take a look at this in action. What you're looking at is me using the AWS CLI to download 100 1-gigabyte objects to an EC2 instance. The default CLI on a new instance, nothing special here, takes about 8.5 minutes to complete. But we're going to now tell the CLI to use a CRT as the preferred transfer client. And we run that same command a second time. This time, we see that it takes just under 4 minutes to download that 100 gigabytes of data. And that's more than a 2x performance improvement for what amounts to 1 line of configuration change. In fact, we're very pleased with the performance and stability of this. And so it is the default on many EC2 instance types, including the Trainium 1, P4D, P5 instance types. So in addition to the AWS SDKs and the CLI, where can we find the CRT? Well, a common theme that we've heard from customers is that they are using software or applications that were built to expect a file-like API. And more importantly, they cannot easily, or maybe it's even impossible, to make changes to these applications to use S3's REST APIs natively. Now, those customers wanted a way to give their applications access to Amazon S3 with the same stability, performance, and technical support that they get from S3's native APIs and SDKs. And so we built and launched MountPoint for Amazon S3, which is an open source file client that makes it easy for your Linux-based applications to connect directly to Amazon S3 buckets and access objects using file APIs. So MountPoint will present your S3 objects as files in your local file system, and it will translate your local file system calls, things like fopen or read, into an efficient use of S3's REST APIs. With MountPoint for Amazon S3, you can achieve high single instance throughput to finish your jobs faster, and you can reliably scale up and down across multiple thousands of instances to read and write large objects, processing petabytes of data. One thing that we heard from customers very frequently is that they are using MountPoint to run jobs that talk to the same bits of data over and over again. So we added a feature to MountPoint that allows you to store your S3 objects on EC2 instance storage or on an EBS volume, particularly to reduce that cost of repeated data access. And most importantly, wanted this to be easy to use, just like everything else with MountPoint. So the only thing you need to do to benefit from this is to specify a directory in which to save the objects, and MountPoint will do the rest for you. So ML workloads, like image recognition, is one example of that type of repetitive access. In an ML training job, we typically see multiple epochs of training, where each epoch is a pass through the entire training data set. And here in this example, we can see that having to reread those individual image files multiple times can limit our training throughput. But when we enable the caching feature, we can see that we're not downloading data from S3 after that first initial load, instead loading it from local storage. And for this ML training job in particular, it led to a 2.5x improvement in training throughput, again at the cost of a single line of configuration. MountPoint for S3 is entirely open source, and it's available for production use today. You can scan that QR code if you'd like, but the GitHub repo is there for you to find as well, where you can learn more about it, including instructions on how to install it on your EC2 instances and elsewhere. So as we wrap up for today, let's put it all together with the 4 immediate steps that you can take. The first is go explore S3 Storage Lens for free to get insights into your storage and find opportunities to optimize your cost immediately. Use S3 Intelligent Tiering to optimize cost automatically, or using the learnings that you've taken away from Storage Lens, make use of one of our specialized storage classes. Then optimize your storage performance by putting in place a key naming strategy that helps us scale with you, and turn on the CRT for automatic request parallelization and latency improvements. And of course, finally, once you've done all this, put your data to work with services like Athena, SageMaker, Bedrock, and more. Just before I leave you, I do want to recommend that you take a look at AWS Skill Builder, our online center, and explore the over 600 free digital courses, hands-on labs, and role-based games, where you can take learnings like the ones that you've seen today and apply them in practice, and of course, learn about many other things. Rushi and I will be around here in the corners to take your questions or dig into topics of interest. I would encourage you to fill out the survey so that we can get better at our job. And otherwise, thank you very much for your time and attention.